In previous lessons, we talked about how to ensure an analytic accurately represents the original intent and how to check and improve performance, precision, and recall. Now let's go over how to expand the time, terrain, and behavior the analytic covers so it can be used in production. By the end of this lesson, you'll be able to demonstrate how to expand the dimensions of time, terrain, and behavior to improve your analytics. Once we are satisfied with the performance, precision, and recall of an analytic, we can expand either the time or the terrain window. By expanding the scope in time, we might uncover new event patterns on weekends or nights, for example. We might find long-term trends in the data that could be used to further refine the analytic. By expanding the scope of terrain, by including more hosts, we might find that there are servers, developer hosts, system administrator machines, systems being updated, or other anomalous systems that exhibit different behavior that we need to account for in our analytic. Ideally, we want to continually expand our time and terrain windows until we have achieved a production level that includes all the systems in scope for our hunt or our continuous monitoring, and over enough time to see relevant trends. Each time we increase the scope, we should reevaluate the performance, precision, and recall of the analytic for the new window and make any necessary adjustment to get those back to acceptable levels. We've included several common increments that we can use when expanding the time and terrain windows. It is often easiest to start with a single host, especially if we have a machine with emulated behavior on it. Expanding next to a small group of machines for which we have good insight about their activity is a great step. From there, we typically run the analytic on a small group on the production network to get a sense for what the real environment should look like, and then start evaluating against larger and larger increments until we get to the full network. On the time side, example increments might be starting with running the analytic over data from the past hour, let's say, and then go back a day, then maybe expand that out to the previous week. You might even go back a month or more until we get to the desired time window. Keep in mind that not all analytics need to be run over this much time. For example, analytics that are meant to run in real time will often only be run over a couple of minutes of data at most. In those cases, expanding the time window is meant to help understand how the results might fluctuate with time of day or day of week. So poor performance during this test phase isn't as big a concern since the production analytic will only be run over a small slice of time. Now, throughout this lesson, we've talked about checking the precision and recall of your analytic as you expand the time and terrain windows and refine your query. But how will you know those numbers if you don't have any known malicious behavior in your data? This is where purple teaming really comes in. To quickly iterate analytic improvement with collaborative adversary emulation. To learn more about purple teaming, watch our Mad Purple Teaming course. But let's talk about what you need to know as a detection engineer or threat hunter. Purple teaming is an iterative and collaborative process of checking and improving cybersecurity measures through realistic, prioritized adversary emulation. Rather than a traditional red team or pen test, the threat emulators and defenders collaborate with the explicit intention of identifying gaps and improving defenses. As defenders, we want to start with an understanding of what we're trying to evaluate or improve. We might know that what we need to improve based on operational experience or by analyzing our likely threats and mission risks. For this course, we're starting with the question of how well our analytic detects the malicious behaviors we're targeting. Normally, the emulator will perform a single activity or related group of activities, and then analysts check if their detections worked. If not, they can work with the emulator to figure out how the activity was performed so a detection method can be developed. This gives analysts an opportunity to test their detections on real activity, as well as give them insight into how well their detections function. This method of analytic development greatly benefits from a knowledgeable threat emulation team who deeply understand the CTI and has the technical skills and procedural experience to implement realistic and safe emulation. We also need network owners who are comfortable taking a risk by allowing malicious activity to be conducted on their networks or in their labs. Ideally, we want to be able to purple team in a production environment so we have real background activity generating false positives. And the analytic we develop is then already implemented in our production scene. As a backup plan, though, we could use a virtual environment. This greatly reduces the risk to our production systems and allows us maybe some more freedom and flexibility. But the downside is that you won't have all the realistic scope, scale, variety of background activity going on in that synthetic environment. You'll need to generate as much as you can, but in the end, you'll always need to retune your analytics when you port them from that purple teaming artificial environment back into your production systems. After we have incremented our time or terrain, we should consider adding some emulated behavior to the data if we haven't done so already. We may also need to try adding more if we are searching a new time range or different hosts than we were in the previous iteration. Again, the objective of doing the threat emulation is to generate true positives, representing adversary techniques for us to search for when assessing and improving our analytics. When emulating behavior, we may repeat techniques we have already performed in order to validate that our analytics are still detecting previous techniques. Or we can add additional implementations of techniques to push the boundaries of our analytics and make sure they encompass all implementations, including those we may not have thought of during the analytic design stage. When we add new behaviors, we need to pay particular attention to identifying those new behaviors with our analytics, but not at the expense of our other detections. Bear in mind that emulating behavior through these specific implementations might still leave gaps in your detection abilities. So this approach should be paired with the more theoretical research and analysis we covered in modules 2 and 3. Our time, train, and behavior paradigm also applies when emulating adversary behaviors. In the time dimension, we need to consider over what time ranges the adversary we are emulating normally acts over. For example, some adversaries might try to do as much as possible quickly before they're caught. Other adversaries are more low and slow, so there are long periods of time between actions, which might make it harder for an analyst to find. From a logistical perspective, we should consider the trade-offs of executing the emulated activity before we begin the purple team or during it. By emulating ahead of the purple team, the blue team won't be able to use a date time stamp as a crutch to find the malicious behavior, which forces analytics to deal with a wider range of background activity. However, by emulating during the purple team, we have more opportunity for collaboration and feedback between analysts and emulators. For example, the emulators could run a new implementation of the behavior specifically designed to help test the edge cases of an analytic. If time permits, emulating activity before and during an event can provide the best of both worlds. Planning a purple team takes time, and it makes sense to do some dry run rehearsals. And that's a great opportunity to inject that pre-event malicious activity into your logs to enable this combination of approaches. Now, for the train aspect, we need to consider how much of the network the emulators should touch. This can range from a single machine to putting the whole network in scope. This is informed by where we are in our analytic development, as well as policy considerations, privacy, and what you've been approved for if you're working in the production network. So, for example, If we are trying to quickly iterate on one analytic and are focused on one host, then it doesn't make sense to have the threat emulators conducting a full campaign across the entire network. As our analytics improve and mature, larger and larger scale exercises begin to make more sense and are more worth the investment of time and money. Emulated activity is often confined to a small subset of a network due to policy constraints, but the blue team could still run their analytics across the entire network to get the benefit of a wide spectrum of real background activity, even though the emulation is restricted to a small subset. This can be aided by not revealing to the blue team what that down-selected subset is, so they're forced to search over the entire production network. Finally, we'll need to ensure the emulation occurs on machines that are relevant to the behavior we're trying to detect and where we've implemented logging on those systems as needed for our analytic. When deciding how to implement the behavior, we could decide to restrict the emulation to only what is directly supported by CTI, or we could give the emulation team more freedom to implement the behavior in new ways. Now, in practice, the emulation will likely be a hybrid of these two extremes. By grounding the emulation in CTI, we can focus on documented threats and prioritize those over hypothetical attacks. However, some degree of freedom is almost certainly going to be necessary to accommodate gaps in the CTI, updates to the target application or operating system, or differences in our production environment relative to the systems targeted in the CTI. The real choice will be how much more flexibility to give the emulation team beyond the minimum needed to make the capability work in our environment. Deviation from CTI should really only be done intentionally and with all parties understanding the deviation. Once an analytic is proven to work on known implementations, it can be useful to allow the emulation team to deviate from known CTI to stress test the analytic and force the analytic developers to think outside the box and better understand the limitations of the analytic. These kinds of activities can often result in new ideas for analytics to detect them, feeding back into step one of our process. Just be careful to avoid the slippery slope of inventing entirely new implementations that deviate so much from the CTI that they are very unlikely to be seen in real life. There are factors beyond just the time, train, and behavior components when considering emulating behavior. We should consider adding context around emulating that adversary's behavior. Implementing the behavior in isolation can be a relatively fast and easy way to do the emulation and generate the associated network traffic and logs for analysis. Keeping the scope small in this way can also leave time and resources for more exploration within the technique, such as different procedural implementations. However, real malicious campaigns are conducted as a sequence of techniques, and having realistic precursor and follow-on activities emulated adds realism, and additional logs and traffic for you to use in refining your analytic using that context. Finally, consider when to use a transparent and cooperative mode and when to be more opaque in your purple teaming. Transparency enables collaboration and is our recommendation for most use cases. However, there is some value in limiting transparency as well. By keeping certain things hidden from the blue team, it can help them accidentally cheating, where the blue team uses knowledge about the event to create analytics that are effective during the event, but won't detect real malicious behavior in the production network. For example, knowing the system used to launch the malicious activity, or the target system, or knowing the parent process used to spawn the emulated behavior. These are all details known by the adversary emulation team, but won't be known by the defenders during a real attack. Lastly, if you recall the analytic development cycle, there is an optional part where we can perform adversary emulation behavior prior to going into the first cycle. It can be useful to generate events prior to the analytic evaluation, like when we search for the event in order to ensure that the analytic is not over-filtering. Going back to our discussion about precision and recall, it does not necessarily need to be representative of adversary behavior, but can serve to provide us flags to look for. Let's take the scheduled task, for example. Prior to running our analytic looking for scheduled tasks, we can create a scheduled task using the command line or the GUI to act as a test that we can find, and we can name it something like test so we know what to look for when we're evaluating the results of our analytics. This can be especially helpful for the validation part of our analytic checking. When we're doing this, it's often easy as the analytic developer to just test on one host in order to narrow the window and allow us to iterate faster. If there are problems finding it, it could be because we're not executing the behavior correctly, or maybe there's a problem with the sensor or sending data. And so this is all good to do early on in the analytic development process, just to check the basics and make sure we're doing those correctly. In this lesson, we talked about an iterative process of improving an analytic by progressively increasing the time, terrain, and behavior it can cover. We discussed tips for how to employ purple teaming to explore the variability of the malicious behavior so we can improve recall and make our defenses more difficult to evade.